Welcome to the Seica booth here at Semicon West. I'm delighted to be joined by Dave Siglio. Nice to see you again, Dave.
Thank you for having us.
Okay. Now, we know Seica very well from the SMT assembly side of the business, but of course we're at a semiconductor back-end packaging show, and you're here to show that side of the business. Maybe you can tell us a little bit about it and how you're set up here.
Correct. Thank you very much for the introduction. Yes, so Seica is a well-known OEM for traditional in-circuit test systems, functional test systems, flying probers, and laser selective soldering systems. We've expanded our horizons and moved into the semiconductor market, and we've recently hired on David Webb as the National Sales Manager for Seica USA, and we're selling and distributing other products from Europe into North America.
Right, okay, and I believe you're going to introduce Dave, who's going to join us here today. So maybe Dave, you can tell us a little bit about how you have things structured over here for Seica assembly.
Yes, thank you, and thank you, Dave. And we have put together several partners in place to bring a turnkey solution to our customers as well as independent solutions. So I think what you'll see in our booth today in a couple of examples is a strength that probably isn't felt normally in the United States in the semiconductor realm.
Okay, great. So we're going to look at a couple of the products on the booth. So let's move on now and take a look at the first of these machines, the Neo Handler.
I'll introduce the CTO of the handlers, OSAI.
Okay, so Dave, we're here now in front of the first of your testing machines. Maybe you can tell us or introduce us to Marco here, who's going to tell us about it.
Yes, OSAI is one of our partners, a strong turnkey partner, and we're showcasing them today here at Semicon. So, Marco, I would like to introduce Marco GUOLO as the CTO, Chief Technical Officer of OSAI.
All right, nice to meet you, Marco. Okay, so maybe you can tell us a little bit about this this tester. I believe it tests for pressure, for humidity, and temperature.
In general, this is a MEMS test handler. MEMS means sensors. We have a lot of sensors with us in our mobile devices, in our phone, in our tablet. And the MEMS sensor for consumer are very high runners in the semiconductor market. And this is a handler designed for MEMS. It means that it can test MEMS, but it can especially stimulate the MEMS. So MEMS means microphones, pressure sensor, means magnetometer, the e-compass that we have in our cell phone. And this machine is capable to test and to stimulate in a proper way. It's a modular system. It means that can grow with the customer needs. It can start for a very simple configuration with a low productivity, but it can be upgraded on the field, and it can be also scaled to different kind of businesses. It's a configurable system, also in terms of stimuli. It can be reconfigured, for example, from a microphone to a pressure sensor, and it's always the same base machine. The machine is very reliable, very stiff. We installed more than 300 of these machines in the field so far, working 24/7, and we have a very stiff granite base inside that gives the machine the capability to have a repeatability of 5 microns inside of the handle.
Plus or minus 5 micron accuracy with the granite base.
Yeah, and this is very important when you are handling multiple devices. For example, this machine can handle up to 35 devices at a time, and very, very small package, like less than 2 millimeter by 2 millimeter. This means that the repeatability is very, very important, and this is what we have. And another interesting feature of this machine is that it is self-teaching, self-programming. We have up to 7 cameras inside of the machine that are capable to understand where the things are, where are the devices, where is the socket, where are the trays, and it can self-learn without any intervention from humans to teach the handler what to do. So this is making the things very reliable. Also during change kit, conversions, and so on.
So you just set the parameters and you let it go. What the cycle times, I assume, are going to be different on each test. What can you give us an idea of what we're looking at?
Yeah, basically, the test time is driving the throughput that you can obtain, and with a reasonable, let me say, average test time of 10 seconds, we can get more than 25,000 UPH from this machine. That it's really a lot. Yeah, really a lot. Consider that there are companies that are producing millions of sensors per day, so they need very high throughput machines.
Absolutely. So, just to sort of recap, it brings the devices in on these trays, tests them, and then it sorts them basically, because it sorts them into ones that go into further production or for reject, basically.
You're right. We have also different kind of output of this machine. It's another kind of configuration that we can have. So in a real mass production, it doesn't make sense to retest bad devices because it's a high cost. So we have just the bins where the devices are placed after we found that there are not good devices. Okay.
Now, you have another really interesting product just around the other side of the booth there. It's called, I think it's the Neo Hub or something like that.
It's a TTU. It's a TTU,
okay.
Twist and Tilt Unit.
Twist and tilt.
It's one of the stimuli that we develop for sensors. In this case, it is conceived to test accelerometer and gyroscope, and it's a physical stimulus. In this machine, you can see we have a couple of pressure chamber for pressure sensors, but in case of accelerometer or a gyroscope, there is another device that we have in our cell phones, for example. You need to physically stimulate the device, giving acceleration and giving also angular speed.
So this is to mimic real life use while you're testing it.
Yes, exactly. And all the stimuli that we develop for this mass production handler is also available in a benchtop version. So you can start from the lab by characterization of your devices, finding out how to test it properly, and then once you have all set, you just transfer the stimuli into a mass production handler that is capable to handle, load and unload, basically, the devices from the stimulus chamber.
Right. Fascinating. Well, thank you very much for joining us today, and that's been very interesting. David, if you want to come back and join us here, we've got another one thing we're going to look at here on the booth, which is on the other side, and you're going to take me around and introduce me to the product manager for that.
Yes, sir. I have another chief technical officer and sales director to bring you to. And the product is also showcasing here at SEMICON, and it's a high voltage, high current test system.
Okay, so Dave, here we are now around at the high voltage tester from CREA. Maybe you can tell us or introduce us to the director of sales for this.
Yes, it's my pleasure to introduce you to MAURO SERRA. He's the director of sales for CREA, and we're glad that he's here at SEMICON with us to showcase his high voltage and high current system. MAURO?
Yeah, thank you, Dave. Thank you so much.
Thank you. Well, nice to meet you, MAURO. Maybe you could tell us a little bit about the high voltage system here and how it works.
My pleasure, my pleasure. Actually, this is a combined platform to cover all the range and the parameter, of this power semiconductor device. It can be configured up to 10,000 amps, 10,000 volts, and it can cover all mainly device available in the market. In a single system, single run, we can do almost all DC and AC verification in a single shot.
So typically what sort of devices and applications are using this?
Yeah, normally this machine has been conceived to be used for power models, and we cover a wide variety of devices. And as I said, once again, we can configure the system based on the customer demand. And the key point in that we have our proprietary technology that is named LSI, that is stay for low strain inductance. And we are capable to be lower than 18 nanohenry at the device. This allows to achieve good measurement for even the new fastest device available in the market right now.
It's interesting. So how easy is it to teach and program?
Yeah, it's very easy. The software is user-friendly. The engineer has no matter about build some, let's say, coding. Some code is just a simple user interface with a basic setup, and immediately he can run and verify the results, either in terms of waveforms or in terms of data availability.
And what about the throughput of boards and devices?
Yeah, the throughput mainly it depends on how many tests it can perform the system. in which the user select how many verification he has to do. But actually we can go from let's say 800 UPH up to 3000 UPH.
Depending on the size of the device and the power and everything else.
Depending even which kind and how many parameter the customer want to verify. Yeah.
Great. Well, thank you for showing it to us today. It's from CREA. Is there a particular model number?
Company that actually is in this market for a long time, from 1992, and we have been always focused on this kind of market niche, power measurement.
So there you have it. That's the latest from Seica here at Semicon West.